In this video, we're going to look at an introduction to surds. To start with, we're going to look at what a surd is, and then we're going to go on to look at simplifying surds. I'm going to start off by drawing two right angle triangles. So there's one and there's the other. I'm going to put some side lengths on. Let's say that this is going to be 3, this is going to be 4, and this is going to be x. We'll say this one is 2, this one is 3, and this is going to be y. I'm going to use Pythagoras' theorem, which we know is a squared plus b squared is equal to c squared. We know if we square the two shorter sides and add them together, this gives us now the longer side, or if you like, the hypotenuse squared. So this one would be 3 squared plus 4 squared is equal to x squared. We've got 9 plus 16 is equal to x squared. 25 is equal to x squared. Taking the positive square root, the square root of 25 gives us x, which is going to give us 5. We can say that 25 is a perfect square. Its answer is an integer. This is what we call a rational number. A rational number can be written in the form a over b, where a and b are integers. Another example of a rational number and a rational square root could be the square root of 36 over 49. We could write this as the square root of 36 over the square root of 49, which would give us 6 over 7. So this is an example of a rational number because we have an integer in the numerator and an integer in the denominator. What we're now going to do is look at this one right here. 2 squared plus 3 squared is equal to y squared. 4 plus 9 is equal to y squared. 13 is equal to y squared. And taking the positive square root, we have the positive square root of 13 is equal to y. What I have here as in my answer is an exact value which we call a surd. A surd is an irrational number. Its answer now, the answer to the square root of 13, can't be written in the form a over b, where a and b are integers. This will give us a non-terminating, non-recurring decimal. Another example of an irrational number is pi. So with pi, the decimal part doesn't repeat or stop. So non-terminating, non-recurring. So this is an exact surd form. We could go ahead and look at a decimal approximation, but certainly when we're dealing with surds, we want to leave them in exact form. This is going to be about 3.6, and we can look at that. So the square root of 13, about 3.6. There we go, 3.6. But this will just keep going. So that is an example of a surd. Another example of a surd could be now the square root of 12. The square root of 12 can't be written in this particular form. If we had, for example, now the square root of 36, this of course is not a surd as it's a perfect square. We could write this now as 6. When we're dealing with surds, we take the positive square root. So this one would be a rational number. If we had, for example, now the square root of 25 over 121, this would give us 5 over 11. So this is a rational fraction and is not a surd. So just because we don't get an integer answer doesn't mean that it's a surd. What we're now going to do is look at simplifying surds. So what we have here is a collection of surds in exact form. The square root of 8 is the exact answer. If we looked at truncating it as a decimal, we would never have the exact value because we would be losing the accuracy when we rounded it. We're going to look at simplifying this and keep it in exact surd form. I'm going to introduce two different rules. The root of a multiplied by the root of a is equal to a. This is really important when we're looking at surds. If you want to try this with numbers, you'll see that it works. So, for example, the square root of 4 multiplied by the square root of 4 is going to give us now, just think about this, 2 multiplied by 2, well that is going to give us 4. Root a multiplied by root a is a. Remember, we're looking at the positive square root here. If we have now the root of a multiplied by the root of b, this gives us now the root of a multiplied by b. So we can write a surd in that form. And that's the property that we're going to use now in simplifying these surds. I'm going to split each of these up as a product, so a multiple of a perfect square and a surd part. So let's look at simplifying the square root of 8. What we do here is look at the factors of 8, and we want the largest square number. Remember, our square numbers are going to be 1, 4, 9, 16, 25, 36, then we're going to have 49, we're going to have 64, we will have 81, 100, and so on and so forth. If I look at the factors of 8, I've got 1, 2, 4, and 8. So the largest square factor of 8 is 4. You certainly don't have to list those out each time, but it might help if you just think, what's the biggest square number I can get into 8 without a remainder? And the answer is 4. What I'm going to do here is write that the root of 8 can be written as, using this property right here, the square root of 4 multiplied by 2. So I have my perfect square here, and then I have this integer value here. We can split this up like we've done here, and write this as the root of 4 multiplied by the root of 2. If we consider now, the positive square root of 4 is 2, so we write this as 2 multiplied by root 2, which gives us now an answer of 2 root 2. And that is a simplified surd in exact form. I've not gone ahead and butchered it. Root 2 is about 1.41. I've not written two lots of 1.41. It's about 2.82. What we do here, and let's just grab this up, and if I typed in here the root of 8, the Casio will simplify it for us. 2 root 2, which gives us about 2.82, 2.83. So that's what we do. We don't need to do this step, we just need to show this one. So that's how you simplify a surd. There is an alternative, and I'm going to do the alternative down here. This is not my preferred method, but you can use it anyway. What you can do is write the number as a product of its prime factors. So if I do 8 as a product of its prime factors, we end up now with 2 multiplied by 2 multiplied by 2. So what we can write is that the root of 8 is going to be the same as the root of 2 times 2 times 2, which is the same as the root of 2 multiplied by the root of 2 multiplied by the root of 2. Using this property here, we can simply write now, we have a pair of these root 2's. That is going to give me 2 multiplied by root 2, which of course is 2 root 2. As soon as I have a pair of those roots that are the same, we end up now with root a multiplied by root a is a. I don't like that method. I will let you use it if you want to, entirely up to you. Let's look at the root of 12. So what's the largest square factor of 12? Well, we can see quite clearly again this is going to be 4. So we write that the root of 12 can be written now as the root of 4 multiplied by 3. This is going to give us now the root of 4 multiplied by the root of 3. That is going to give me now 2 multiplied by the root of 3, which we can write as 2 root 3. So 2 root 3 is root 12 simplified. From now on, I'm going to leave this stage out purely based on the fact that I wouldn't do it in my workings. I would simply show this, 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 and then that. Okay, let's look at the square root of 24. Again, if we think about the factors of 24, we've got 1, 2, 3, 4, 6, 8, 12, and 24. So let's look at those. So what's the largest square factor there? Well, we can see again it's going to be 4. So with this one, what we've got is the root of 4 multiplied by 6, which is going to give us the root of 4 multiplied by the root of 6, which is going to give us now 2 root 6. If you want to check that on a calculator, just type it in. Clearly you wouldn't have a calculator if you asked to simplify that surd, because this is a non-calculator activity. The advantage of this as well is that you can work in exact form when you don't have a calculator. It's fantastic. Certainly, for example, with Pythagoras. And there's lots of different things that you can do. I think whilst we're here, I'll introduce something too. When we're looking at notation, when we are dealing with indices, the half power is the same as the square root. So the square root is a half power. So 8 to the 1/2 power is the same as saying the square root of 8. We would end up now with 2 root 2, and of course 2 root 2 here. So just for future reference. Okay, so let's do the next one. Root of 28. Again, root of 28, if we think about root of 28, the largest square factor is going to be 4. And then we have 4 times by 7. Root of 4 multiplied by the root of 7, which is going to give us now 2 root 7. It doesn't necessarily matter if you get this particularly wrong in terms of not finding the largest square number. So, for example, if we did now the root of 32 and you said, right, let's just write this in, the root of 32, you said, oh, largest square number that will go in is going to be 4. So what that's going to give me is 4 multiplied by 8, which is going to give me now the root of 4 multiplied by the root of 8, which is going to give me 2 root 8. Well, we've already seen that root 2 can be simplified itself, which is the same as saying 2 lots of 2 root 2, which is going to give us 4 root 2. Because what we should hopefully have spotted is that the largest square factor of 32 is actually 16. So this would have given us now the root of 16 multiplied by the root of 2, which is just going to give us 4 root 2. But as you can see, it's not catastrophic if you miss that. So logical, straightforward, just plug the numbers in and split it up. Let's look at the root of 108. The more you do these, the more you'll spot them and almost remember them. The largest square factor of 108 is 36. So we could write this as 36 multiplied by 3, which is a root of 36, multiplied by the root of 3, which is going to give me 6 root 3. 6 multiplied by root 3 is just 6 root 3. Now, you could prime factor that, but as you can imagine, prime factoring the root of 108, the bigger the number gets, the more of a hassle it's going to be. But you could do, if you wanted, and use the property that root a multiplied by root a gives a. As you can see, though, it can be a bit more challenging. So that's what we get. Okay, let's say we were just given this quantity right here, 2 root 7. What we've been doing is looking at simplifying surds and reducing them to their lowest terms. We might be asked to work backwards. If we're asked to work backwards, all we do is square this number here out front and multiply it by the one under the root. So that's what we would do, which would give us now the root of 28, and we saw that before. So if you need to work the other way for some reason, if you're given something to work the other way, simply take the number out front, square it, and multiply it by the number under the root. So if you look at this one right here, if we took 6 root 3, we can say now that this is going to be the same as 6 squared, which is 36 multiplied by 3, which is going to give us the root of 108. Because for this to come out, what we've essentially done is square rooted this quantity. So all we do is the inverse, we square it and it comes back. Okay, root 40. So we can write this now. Largest square factor is again going to be 4. That gives me 4 times by 10. We can write this as root 4 multiplied by root 10, which is going to give 2 root 10. Hopefully now you're up to speed and you're probably ahead of me, and I'm kind of hoping you've gone ahead of me. And we'll probably catch each other up at some point. The root of 50, largest square factor is 25. 25 times by 2, that's going to give me root 25 multiplied by root 2. Root of 25 is 5, 5 root 2. Again, you can check them on a calculator if you want. Root of 18, largest square number that goes into 18, that looks like it's going to be 9. 9 times by 2, root 9 multiplied by root 2, which is going to give us 3 root 2. Again, if you didn't spot that, prime factor it, divide it by 2, that gives me 9, divide it by 3, that gives me 3, and we end up now with the root of 18 is the root of 2 multiplied by 3, which you could write as root 2 multiplied by root 3 multiplied by root 3, we have a pair of root 3's, so this is going to give us root 2 multiplied by 3, which of course is 3 root 2. Alternative approach if you wish. Root 48, largest square factor of 48, largest square number that goes into 48 with no remainder. I think that's going to be 16. 16 times by 3, so root of 16 multiplied by the root of 3, square root of 16 is going to be 4, and then we have root 3. Remember, with surds, we always take the positive square root, or the principal value, if you like. So we don't write 4 plus or minus root 3, we just write, or whatever you would write, or want to write, we just go ahead and do that. Okay, square root of 32, we've already seen this one. Root 32, well, we can write this now as the root of 16 times by 2, which is the root of 16 multiplied by the root of 2, which is 4 root 2. Root 20, we can say now that the largest square factor is 4. 4 times by 5, that's going to give us root 4 multiplied by root 5. Square root of 4 is 2, 2 root 5. Root 125. With cube numbers are quite cool, because if you think about a cube number here, 125 is a cube number, it's 5 times 25, 5 times 5 times 5. So we'll just write this now as that. That's going to give me root 25 times by root 5, which is going to give now 5 root 5. Root 200, another reason I don't like prime factoring, because this will take forever. Logical here, 100 multiplied by 2, that's the largest square factor. Again, if you hadn't spotted that, if you thought it was 25, that's fine. Then what you've got is the root of 25 multiplied by the root of 8, and I'll show you that again. So root of 100 multiplied by the root of 2, root of 100 is going to give 10, 10 root 2. So let's say you didn't spot that and you said, well, the root of 200, let's go for, we'll say the root of 25 times by 8. 8 times by 25 is that. So that's going to give me now the root of 25 multiplied by the root of 8. That's going to give 5 multiplied by the root of 8. And then you thought, oh, well, root 8 is actually 2 root 2. So you can see now that we're picking this back up. 5 times 2 root 2 is going to give us now 10 root 2. So not the end of the world if that happens. Okay, 216. Well, let's look at 216. If we think about now 216, the largest square number that goes into it, well, this is a cube number. So with 216, this is going to be, let's write this out, 216 is 6 cubed, which is the same as 36 times 6. Square root 36 multiplied by square root of 6. Square root of 36 is 6, 6 root 6. So again, if you were given this and you had to work backwards, simply square this number, multiply it by the number under the root, and that will give you the original unsimplified surd. Right, let's look at the next one, the square root of 192. So, square root of 192. If you're struggling here, let's just take a logical guess. 64 times by 3. That looks pretty good. 3 times 64 is going to give us 192. So root of 64 multiplied by the root of 3. Root of 64 is 8. 8 root 3. So that's what we end up with. Let's look at the next one. What's this going to be? Root 320. I think that's 64 times by 5. Let's see if that works. So root 320 is going to be the root of 64. 64 times 5. That looks pretty good. So root 64 multiplied by root 5, which is going to be 8 root 5. Again, you just kind of, I wouldn't say wing it, but think, what's the largest square factor of 320? You could try and locate it if you really wanted, or you could prime factor it if you wanted to do the factors. 1 times 320, 2 times by, what's that going to be, 160. Can't divide it by 3, can divide it by 4. What's that going to be? 80, 4 times by 80, because we're just halving that, aren't we? And then the next one is for 5 times 64. So that's what we get. So you can see now that the largest square number that's going to go into it is 64. Do I like that? Well, again, it's entirely up to you. You decide on how you want to view that. So there we go, that's just simplifying surds. We find the highest, the largest square factor of a number and split it up